Let's go to Black Book. Justin, your turn to shine, baby. All right. Raggy trombone. One of Borovich's favorites.
I think it's Lassus trombone.
Raggy and
that
Lassus.
That one you got to be careful about. I think that was one of those blackface pieces.
Well, the next one is Broadway.
Yeah.
You doing Raggy?
Yeah, just a minute here. Actually, yeah, we'll do this, and then we'll probably be ready for the procession.
All right, I'll start it.
Let's get the processional set. Banky.
So that starts at 9:20.
Okay. So we got 2 minutes of sound separation.
Mikey Glader's marathon to play 30 minutes of prelude music for the wedding. We have to play ceremony. Then we have to play an hour of cocktail music.
The first number on that check better be number 5.
Yeah.
It better be.
That plexiglass, good little sun glare.
I know my books have like the sheet protectors, but that sometimes causes a problem because you get like a glare off the sheet protector.
You say you sound bad.
Justin, have you ever played the Adson before?
No.
Okay. So on the first air, see where it's in 3/4 towards the end of the first air?
Yeah.
Yeah, that'll be in 1. Bing, bing.
All right. And then is the second one.
We're ready to start? Okay. Banky Single.
Take it's not that fast. Oh no, he doesn't play.
What?
You may be seated. Welcome, everyone, graduates, families and friends, faculty, staff, and honored guests, to Thayer School of Engineering's 2022 Investiture. Woo! My name is Alexis Abramson, Dean of Thayer School of Engineering at Dartmouth, and it's an honor to serve as your Master of Ceremonies today. At Dartmouth's commencement tomorrow, Thayer School of Engineering will award 162 degrees, 106 in Bachelor of Engineering, including 40 AB/BE combined degrees, 7 degrees in Master of Engineering, 21 degrees in Master of Engineering Management, 5 degrees in Master of Science, and 23 doctorates. In addition, Dartmouth will award 113 Bachelor of Arts degrees in engineering sciences. So let me be first to say congratulations to this remarkable class of 2022. Even in times of great uncertainty, you have pushed the boundaries of curiosity and creativity, research and innovation, resilience and resourcefulness. Through it all, you have created significant impact in our community here and in the world beyond. Of course, no graduate reaches this milestone alone. I also want to acknowledge your family and friends, both here and at home, who have supported you throughout your journey. Your incredible faculty who taught, advised, and mentored you, and who, for many of you, have become like family. And our dedicated staff, who, in addition to supporting you and our faculty, have worked tirelessly to plan, organize, and volunteer their time at this ceremony. It is now my privilege to introduce our honored guests and faculty and student marshals. So to my immediate right, Dava Newman, Director of MIT Media Lab and Professor of Astronautics, who will deliver our keynote address. Dartmouth Provost David Coates, and Dartmouth President Philip Hanlon. And to my left, Chair of the Dartmouth Board of Trustees, Elizabeth Lempres, Member of the Dartmouth Board of Trustees, Daniel Black, Chair of the Thayer Board of Advisors, Sam Truex, and Thayer Board Member, Peter Fahey. And behind me, with the Thayer faculty, Laura Ray, Myron Tribus, Professor of Engineering Innovation and Senior Associate Dean for Faculty Development, Doug Van Sitters, Associate Professor of Engineering and Associate Dean for Undergraduate Education, and Jeff Parker, Professor of Engineering and Executive Director of the Master of Engineering Management Program. I also want to recognize the distinguished faculty and students who led our procession this morning. Faculty Marshal and newly promoted Professor Jifeng Liu. And of course, our student marshals, BE candidate Abigail Brazil, MEM candidate Ivan Cornish Morales, and PhD candidate Alicia Everett. Thank you all. So it is now my pleasure to introduce our provost. David Coates was appointed Dartmouth Provost earlier this year by President Hanlon to oversee academic operations and advance initiatives that enhance the college's teaching and scholarship. Throughout his time at Dartmouth, he has served as Associate Dean of Faculty for the Sciences, as Executive Director of Dartmouth Institute for Security, Technology, and Society, co-leader of the Center for Technology and Behavioral Health, and as interim provost. His research has focused on security and privacy risks associated with consumer-based smart technologies, and he has advised and mentored more than 100 students and researchers through his years at the college. Most notably, Dave is a proud alum, having earned his AB in computer science and physics, and we are honored to have you address our graduates today. Please welcome Provost Coates.
My warmest greetings to you all on this beautiful day. Greetings to President Hanlon, to Dean Abramson, to my Thayer colleagues, to members of the Thayer Board of Advisors, to our distinguished speaker, Dava Newman, and most of all to our graduates, their families, and guests. It's my great pleasure to join you, especially right here and right now. Here, where we literally sit at the crossroads of the West End, where talented students and faculty from engineering, computer science, entrepreneurship, energy, and business all converge into one incredibly synergistic community. And now, here at this transformative moment for Dartmouth as we expand computer science and engineering, launch the new Irving Institute for Energy and Society, and strengthen their bridges with Magnuson Center for Entrepreneurship and the Tuck School for Business. This place and this moment resonates with me personally as a former student of computer science and engineering at Dartmouth, as a current member of the Faculty of Computer Science, as the proud parent of 3 Dartmouth students who have taken Thayer courses, and as the proud provost who now has the honor to work closely with the leaders of Thayer and its neighbors to bring the West End to life and to help it achieve its highest potential. As a professor, I am also filled with great pride to celebrate today with you, the Thayer graduates of 2022. You who will soon leave the Hanover plane for the wide, wide world will be tomorrow's leaders of the 21st century, a century that portends tremendous advances in technology that will surely change our world. You will be at the helm of those changes, whether as leaders of engineers developing the technology, as leaders of enterprises deploying that technology, as leaders who shape public policy around the application of technology to address the many challenges the world will face during this century. As a computer scientist whose office now sits in a building alongside my esteemed engineering colleagues, I've recently been thinking a lot about one class of emerging technology, autonomous systems. To me, an autonomous system is an engineered system that can sense and interact with its environment autonomously with little or no help from human operators. Think of it as the convergence of engineering, computer science, and artificial intelligence. I'm sure you've heard of one type of autonomous system, autonomous vehicles, such as self-driving cars and trucks, robo-taxis, and things like that. These technologies offer tremendous potential to increase safety and efficiency in transportation and to enable transportation to members of our society who currently find it difficult to get around, such as the elderly or infirm. They also hold tremendous potential for disruption, as a whole category of jobs, like truck drivers, might disappear. So one can envision many other forms of autonomous systems in sectors like agriculture, manufacturing, shipping, disaster recovery, and even surgery. Each presents tremendous opportunities for innovation by engineers like you and computer scientists like me, but also each poses tremendous challenges related to ethics, policy, law, and society. How do we design and use these incredible technologies in a way that benefits society without creating further inequity and injustice? How do we ensure the security of these technologies so they cannot be hacked and misused? How do we protect individual autonomy, dignity, and privacy? How do we enable the technological feats that enhance society and restore the health of our planet while avoiding the potential use of these technologies to, for example, create autonomous weapons that would bring the concept of warfare into an era far more deadly and frightening than ever seen in history. These kinds of questions will challenge us all and require input from a diverse range of disciplines, backgrounds, and communities. It is for this reason I am proud to be at Dartmouth, where engineers are trained in the context of the liberal arts. Thayer engineers understand that engineering does not exist in a vacuum, that technology is at its best when we consider the human context in which it is used, when it is applied in ways that improve the human condition and restore the health of our planet. I have great confidence in you, Thayer graduates, as you become the leaders of the century ahead. My best wishes to you and your families. Congratulations.
Thank you, Provost Coates, for those words of wisdom. It is now, it is now my privilege to recognize members of our community for their academic achievements and distinguished service. Students, when your name is called, please approach the platform using the stairs to your left, my right, then exit the stairs on the other side of the stage. The Thayer Faculty Award for Academic Excellence goes to the students with the highest academic performance in the Bachelor of Engineering program. This year's prize goes to Basil Mataneze, Nolan Sankey, and Musab Shakil, who have all earned a 4.0 grade point average in their engineering courses. Congratulations. The Dartmouth Society of Engineers Prize is awarded for outstanding performance in an engineering project by a Bachelor of Engineering student or student team. This year's prize goes to the team of Kieran Ahern, Kate Boydston, Iva Devick, Brendan Killarney, and Abby Wiseman. An essential part of this student experience, Dartmouth Skiway faces a significant threat from climate change, including social and economic issues from changing weather patterns. This team produced a comprehensive plan to enable the skiway to reduce its carbon emissions by 284 metric tons per year in a feasibility and financially sustainable manner, and serve generations of future Dartmouth students. Congratulations. The Charles F. and Ruth D. Goodrich Prize is awarded to an engineering student in recognition of outstanding achievement with special emphasis on academic excellence. This year's prize goes to Safer Rahman. A PhD candidate at Thayer, Safer is a highly collaborative and creative researcher who has made significant contributions to several projects in the area of flexible electronics. He is co-author of 3 high-impact journal publications and is first author of a manuscript currently in revision at NPJ Flexible Electronics on the topic of low-power wearable sensing based on modulation of the electromagnetic skin effect in liquid metals. Safer serves as a mentor to BE students and has recently been selected as a PhD Innovation Program Fellow. He is currently completing an internship at Facebook's Flexible Electronics, so could not be here with us today, and I look forward to seeing what he will accomplish when he returns to Thayer. The Thayer Corporate Collaboration Council Engineering Management Prize honors outstanding performance in the ENGG 390 internship and project by a MEM degree candidate. This year's prize goes to Neha Bharti. Neha's work on her project, Supplier Quality Platform for Tesla, left her advisor, Mark Cantrell, extremely impressed, saying that her ability to organize the data systems across factories and supplier organizations in order to share improvement practices will have an enormous positive impact. Neha will soon put her valuable skills to work full-time as technical program manager for Google in Durham, North Carolina. Congratulations. The Carolyn Henderson Prize is awarded to the Master of Engineering Management degree candidate for highest academic achievement and outstanding service. This year's prize goes to Denise Kellish. Denise's superior academic performance will hopefully serve her well in her new job as data science sales engineer at Fidelity Technology Group in Boston. Congratulations. The John C. Woodhouse Engineering Design Prize is awarded for innovation and ingenuity in developing the most inexpensive but effective experimental research equipment. This year's prize goes to the team of Theodore Bronk, Grayson Campbell, Riam Chowdhury, Joshua de la Cruz, Basil Montagnez, and Yutong Linda Xia. If you could join us up on stage. Peripheral nerve injury can lead to a significant decrease in quality of life, and traditional approaches to repair can be slow and ineffective. This team developed a 3D printed nerve coupler that holds the ends of a damaged nerve together while allowing for polyethylene glycol application to stimulate nerve fusion. Their in vivo proof of concept tests were successful, and they are poised to take the next step towards future clinical development. Congratulations. The John C. Woodhouse Environmental Engineering Prize is awarded to an individual or team for the best work in the field of environmental study or research. This year's prize goes to the team of Peter Ammons, Van Guarnieri, Bridger Holler, and Tyler Stern. Electric propulsion systems for performance boats in the trend-setting 14-meter range offer significant potential environmental benefits. The industry standard of diesel engines damages the atmosphere, pollutes the water, and produces noise at a disruptive level for marine life. Rim-driven thrusters are inherently electric with potential to replace diesel propulsion systems and address these environmental concerns. This team not only mitigated 7 technical risks over the course of the project, but also designed and characterized a 1 kilowatt physical prototype of the proposed concept. Congratulations. The Brianna S. Weinstein Engineering Design Prize recognizes a student or student team for the design and development of a new technology or system that benefits people, particularly children or adolescents, with physical or developmental disabilities. This year's prize goes to the team of Abdibasad Bar, Sophie Goldberg, Moses Montada, and Kira McLaughlin. Worldwide, about 15 million babies are born prematurely each year, and 30 to 50% of babies born before 31 weeks develop respiratory distress syndrome that requires continuous positive airway pressure treatment. Hospitals in low and middle income countries often lack the correct size nasal cannula for these babies. So this team developed a novel CPAP nasal interface to provide a universal fit at low cost. The design incorporates a multimodal solution that accommodates a wide range of anatomies by providing one-time adjustability in nares width, head circumference, and facial length. Congratulations to the team. The John W. Strobane PhD Memorial Prize is awarded to a student in recognition of outstanding performance in engineering and medicine. This year's prize goes to Samuel Streeter. Sam has maintained a straight-A average through his AB, BE, and PhD work and has generated 12 publications to date, with 6 as first author. He has won dozens of prizes for posters and talks at conferences, including funding to present at an SPIE conference in Japan. In addition, he served as a lead TA for the Advances in Biomedical Engineering course and earned numerous citations for his roles as TA. Sam is an outreach fellow for high school programs and is always willing to offer others advice and help them with their work. He will finish his PhD in August and has accepted the position of research scientist in orthopedics here at Dartmouth Health. Congratulations. The Dartmouth Engineering Prize for Graduate Research Excellence is awarded to a PhD student who has demonstrated outstanding research excellence during their graduate study. This year's prize goes to 2 recipients, Mahboober Rani Rahman and Prescott McLaughlin. Ronnie's commitment to research is truly inspirational. He has published some of the most impactful papers in the emerging field of ultra-high dose rate radiation therapy, otherwise known as flash radiotherapy. He was the first person in the world to develop and publish conversion procedures from flash to conventional irradiation modes on clinical linear accelerators and at normal treatment geometries. The first in the world to create a beam model for treatment planning of flash beams, and the first to use these tools in preclinical animal trials. He holds a publication track record that is more in line with well-established postdocs than a PhD candidate, with 14 publications in peer-reviewed journals, half of these as first author. Now, Scott McLaughlin has also had an impressive research trajectory, including 2 major contributions to advance state-of-the-art power electronics. His seminal paper in IEEE Transactions on Power Electronics, in which he has published as first author, culminated in a multi-year, multi-student analysis and comparison framework for the emerging class of hybrid resonant switched capacitor DC-DC converters. His second contribution was to develop an on-chip integrated LC resonator passive component on the same die as the power converter, achieving an unprecedented combination of power density as well as efficiency. Congratulations to both of you. The Special Faculty Award for Engineering and Service to Humanity recognizes a student or student team in any degree program for exemplary achievement related to the application of engineering in service to society. This year's prize goes to the team of Samira Afreen, Garrett Andreen, Sydney Friedland, and Musab Shakil. Over 37 million people in the US who are deaf or hard of hearing are unable to call 911 in an emergency. Although text 911 is the most promising solution, it is still not compatible with most 911 answering points. For their ENGS 8990 project, this team developed a method for converting text-based information from a web application into an audio message that can be relayed as a call to 911. Working with New Hampshire Emergency Services, the Hanover Police Department, and other stakeholders, the team successfully demonstrated the feasibility of their app to enable a more safe society for all. Congratulations. The Dean's Service Award recognizes a student who has made exceptional contributions to Thayer, Dartmouth, or the broader world through research or work in service to society. This year's prize goes to PhD candidate KJ Jarrett. KJ has made significant efforts to improve graduate student life and to create a more welcoming, inclusive Thayer. As co-president of Thayer Council, KJ developed and led opportunities to facilitate student connections across Thayer. He advocated for and helped secure funding for student groups that serve women, Black and Hispanic engineers, and international students, to provide support to engineering students from traditionally underrepresented backgrounds. He represented Thayer at the National Society of Black Engineers conference to support graduate student recruitment and has served as a mentor and role model to many, all while pursuing his doctoral research in computer vision, machine learning, and deep learning. Congratulations, KJ. The Outstanding Staff Service Award honors members of the Thayer staff for their tremendous and dedicated service. This year's award goes to two individuals, Kathleen Duffy and Daniel Cullen. Faculty describe Kathleen as exceptional, going above and beyond the call of duty as a research administrator, and whose work ethic, professionalism, and positivity is critical to helping faculty navigate complex funding, grants management, and research administration challenges. As lab manager, instructor, and lecturer, Dan is at the heart of many hands-on projects that are a hallmark of the Dartmouth Engineering experience. In close collaboration with faculty, Dan continues to develop projects that enrich student learning and understanding and support students with great patience, care, and enthusiasm in a way that ignites a student's passion for engineering. Congratulations, Kathleen and Dan. The Outstanding Service Award for Faculty honors a member of the Thayer faculty for their tremendous service and dedication over the past year, and whose activities have significantly enhanced the quality of our educational institution and community of scholars. This year's award goes to Professor Laura Ray. Laura has excelled as a faculty leader and mentor. Most recently, she spearheaded successful faculty searches that have led to the hiring of exceptional new colleagues, expanding our research and teaching capacity, and bringing a diversity of new experiences and perspectives to our community. Laura always goes above and beyond to prepare faculty candidates for interviews and support new faculty in their transition to Dartmouth and in their own professional growth. Even more, she works tirelessly to provide support to Thayer wherever and whenever needed. Please join me in congratulating Laura. Thayer's Diversity and Inclusion Award recognizes members of our community for outstanding leadership, commitment, and efforts to raise awareness for and address issues of equity, diversity, and inclusion at Thayer. This year, the award goes to three individuals. BE candidates Ian Cruz and Joshua de la Cruz for their leadership as co-presidents of the Society of Hispanic Professional Engineers. as well as to Professor Rafe Steinhauer for his efforts to help faculty and teaching assistants become more inclusive in their practice. As co-presidents of SHIP, Ian and Joshua have demonstrated a model of leadership that encourages collaboration across boundaries and creates a community within SHIP where both cultural and academic diversity are valued. Through their efforts, they enhance the experience of engineering students at Dartmouth, championing and facilitating student access to resources not widely available. And in his role as leader of the DEI in the Classroom Working Group, Professor Steinhauer and the working group designed activities to increase students, instructors, and teaching assistants' awareness for how equity and inclusion, as well as inequity and exclusion, manifests in the classroom to support learning that fosters inclusive teamwork. Rafe was at the forefront of creating recorded skits this year involving our own students that really illustrate the impact of these lessons. Congratulations. The Thayer Distinguished Research Award honors a faculty member for extraordinary scholarly achievements that demonstrate notable discoveries or research accomplishments through publication, citation, or issued patents. This year's award goes to Professor Keith Paulson. Keith's research focuses on the development and translation of advanced imaging technologies for cancer detection, diagnosis, treatment, and surgical guidance. Along with his team, he has developed and patented tools for intraoperative quantitative fluorescence imaging, magnetic resonance elastography, and image guidance for cancer surgery. Most recently, his team developed a deep learning algorithm that learns from data in near real time to distinguish between malignant and benign tumors. The algorithm shows promising potential to overcome major hurdles in multimodality imaging and improve cancer detection and diagnostic accuracy. Please join me in congratulating Professor Paulson. Our greatest strength is our extraordinary faculty, whose commitment to students and love for teaching is unparalleled. Each year, we honor the best teacher scholar among our engineering faculty. And I am honored to present this year's Woodhouse Excellence in Teaching Award to Professor Vikrant Vaze. I want to let his students' comments speak for themselves. Professor Vaze is captivating. He brings so much energy and enthusiasm, makes us feel more motivated to learn. He excels at connecting course materials to real-world applications and somehow makes it easier for us to understand complex concepts. Professor Vaze is always willing to help his students. He extends office hours around our needs and makes us feel comfortable to go to him with any question. He celebrated holidays and end of term with us. He made me feel included and more connected with my class. Please join me in congratulating Professor Vaze. And maybe one final congratulations to all the award winners. It is now my pleasure to introduce Joshua de la Cruz to deliver the student address. Joshua epitomizes what it means to be a Dartmouth engineer. Throughout his time at Dartmouth, he has consistently demonstrated his commitment to taking on complex engineering challenges, but also to creating a Thayer where every student can thrive. In addition to serving as a student leader, an undergraduate advisor, and teaching assistant, Josh has earned numerous engineering accolades. In 2019, he was part of a Dartmouth team selected by the National Academy of Engineering to represent the United States at the Global Grand Challenges Summit in London. Born and raised in the Chicago suburbs, Joshua attended Dartmouth as a Quest Bridge Scholar, a program that matches exceptional high school students from low-income backgrounds to the nation's top colleges. Tomorrow, Joshua will be the first in his family to earn a college degree. Please welcome Josh Diller-Cruz.
Thank you, Dean Abramson, for the kind introduction. Truly delighted to have the honor to speak to you all today. So if someone would have told me 4 years ago that I'd be standing here giving this speech, I definitely wouldn't have believed him. My Dartmouth experience has taught me so much along the way, but I think the greatest lesson that it's taught me is how to face challenges directly. This is because my experience has been riddled with so many firsts, like being the first in my family to attend a 4-year university, traveling to the East Coast and different parts of the world for the first time, taking a really hard engineering class and discovering my first true passion, navigating college coursework and projects over Zoom for the first time, and so much more. It's easy to say that there have been many trials and tribulations throughout my 4 years here, and I know many of the same experiences that I have had are shared by my peers as well. Yet, despite the first obstacles, we have seen the unique experience a liberal arts college can bring to the life of an engineering student. And that's exactly what makes Thayer such a special community. As a member of the 2022 graduating class, I want to reflect on our time at Dartmouth and at Thayer specifically through an analogy that nearly all of us engineers from BEs to PhDs will understand. And that's the engineering design process. Just so we're all on the same page, let's define the process in 5 simple steps. Step 1, define the challenge or the problem you want to solve. Step 2, brainstorm solutions to that problem. Step 3, put the solutions to action. Step 4, test the solutions using a model or an experiment. And most importantly, step 5, reflect on your results and try again if you fail. Subconsciously or not, this is a process that has dictated so many of the choices we've all made, not only academically, but in life in general. I know that for me, this is the process that I had to apply vigorously to get through some of my toughest classes. Infamously, Engines 23, 31, 8990, basically everything after the prereqs, and let's not even mention Chem 5 or Physics 1314. Now, all jokes aside, the unique characteristic that I see in the engineering design process that many others might not is that it's fearless by nature. And by that, I mean that if you fail in addressing or solving your challenge, the system is made for you to try again. A mentor of mine once told me that the word fear actually stands for an acronym. Fear, false evidence that appears real. As engineers, we decided to study a science that's evidence-driven. And so if fear is false evidence, then let's eliminate that factor from our motto of life. Tomorrow, when we receive our degrees, that piece of paper hanging on the wall should remind you that no matter what challenges you might face in the next chapter of life, you have been given a tool set to face them all. When you apply the engineering design process to your life's journey, step 1 will define the problem you need to solve as, how do I navigate life? What you'll find is that the iterative nature of step 5 won't lead you to any kind of success, but it will help you determine what's most important to you and what purpose you want to have in this life. Our generation as a whole will be tackling some of the most difficult challenges humanity has ever faced, including climate change, food insecurity, international war, economic inequality, and the list goes on. Yet despite the overwhelming uncertainty in today's world, I challenge each and every one of us to lead fearlessly. Let us not be detracted from making an impact in the world because of the perceived limitations imposed on you by yourself, by others, or by society. Think about how much you've accomplished so far and how our preparation at Thayer has shaped us into engineers and scientists capable of doing the hard work. When we face doubt, let us lean on the diversity of experiences and perspectives of ourselves and our peers, leverage our communities and connections, and remember that things that are worth it are not supposed to be easy. As we go our separate ways, remember this mission statement. We are now the most capable and faithful. Thayer and Dartmouth have prepared us for the most responsible positions and the most difficult service. Let us use this and the tools of engineering that we have been given as motivation to lead fearlessly. It has been an honor to be part of the 2022 graduating class, and I'm excited to see the great accomplishments we'll all make in the coming future. Thank you, and congratulations, graduates.
Thank you so much, Joshua. So each year at Investiture, we honor a member of the greater scientific community for their distinguished achievement and service in the highest tradition of our school. In 1870, Dartmouth's then president, Asa Dodge Smith, and our founder, Sylvanus Thayer, tapped a 23-year-old Robert Fletcher, then an Army lieutenant and mathematics professor at the U.S. Military Academy, as our school's first dean and professor. The young Fletcher served as our school's dean and the only full-time engineering professor in Thayer's early years, teaching 14 courses his first year and 36 courses during his second. In the ensuing 65 years, Fletcher left a lasting impression on generations of students, emphasizing engineering as a way to improve lives and serve society. The individual selected to receive the Robert Fletcher Award must possess the qualities exemplified in the life and work of our first dean and professor. And so today, we are honored to name Dava Newman the 2022 recipient of the Robert Fletcher Award. We will be presenting to her with a physical award of acknowledgement of receiving the Robert Fletcher Award along with a medal in the coming days. Professor Newman is the Apollo Professor of Astronautics at MIT, the director of MIT's Media Lab, and a member of the Harvard-MIT Health Sciences and Technology faculty. From 2015 to 2017, she served as NASA Deputy Administrator, the first female engineer in this role, and earned the NASA Distinguished Service Medal. She was the principal investigator on 4 spaceflight missions aboard the Space Shuttle, Russian Mir Space Station, and the International Space Station. As a leading expert in advanced spacesuit design and the dynamics and control of astronaut motion, she's best known for her biosuit, a second skin-like suit for planetary exploration that could revolutionize movement and locomotion during space travel. She is the co-founder of Earth DNA, which aims to accelerate climate understanding and actions for Earth's ocean, land, and air systems, develop artificial intelligence and machine learning open source platforms to produce satellite imagery to help us better understand Earth's vital signs, and to train future climate leaders committed to making the world better for 100% of humanity. In addition to the Fletcher Award, Professor Newman will receive an honorary degree from Dartmouth at tomorrow's commencement ceremony. Please welcome Dava Newman.
Thank you so much, President Hanlon, Provost Coates, Dean Abramson, to all the honored faculty, to the family and the friends who share this very special, actually a most incredible in-person occasion today. Thank you for this great opportunity to be with you and share a few moments of your special day. I'm truly honored and humbled to be here with you today at Dartmouth. Dean Abramson, thank you. It's really amazing. It's touching. This Robert Fletcher Award, I cannot measure up to 14 classes in teaching in the first year, I'm just saying. But what an incredible leader and public servant. And so I know we both enjoyed our time immensely serving in the Obama administration 150 years, to the future after Robert Fletcher. So it is an incredible time. It's been an incredible, difficult time. You have persevered. You have gone through so much. We all have together. We are emerging. I know we all appreciate every day now, and our family and friends so much. So I offer with my sincerest gratitude to you, President Hanlon, the trustees of Dartmouth College, the honor for joining this distinguished academic community with an honorary Dartmouth degree. I'm especially pleased to join all of you, the Thayer Engineers of 2022. Dartmouth Engineers, congratulations. As the Apollo Program Professor, one of my greatest joys is seeing students, just like all of you, turn your dreams into reality, against all odds often. One of my heroes, Eleanor Roosevelt, said simply, quote, "Believe in the beauty of your dreams. You've done more than that. You've not only believed in your dreams, you've turned them into reality. And this is just the start. You have incredible futures ahead of you." Families and friends, dear graduates, how about another huge round of applause for all of our graduates? I spent many years learning, working, and teaching at MIT, and now I call the Media Lab home. Just like the Thayer School, we strongly emphasize transdisciplinary education to realize the synergies among the arts, sciences, engineering, design, and innovation. The goal is to prepare creative, brilliant minds to help lead society in this incredibly complex world with all of our challenges ahead. We envision educating growing humans. Maybe that's growing humanity. I know that's the foci here of Thayer Engineering. Thayer School is one of the oldest and most prestigious schools of engineering in the United States. Today has 35% student body that identifies as female, almost double the national average. Our hard work must continue till we reach parity. Their distinguished alumni include Phoebe Suina, 98 AB, 99 BE, and 2001 Masters of Engineering Management. Phoebe's founded High Watermark in her native San Felipe and Cochita pueblos in New Mexico. It's having significant impact to protect local, natural, and cultural environments for First Nations people. Her philosophy, her actions are really powerful, so I'd like to quote, "We've been in this landscape since time immemorial. First Nations people were the first scientists, architects, engineers, botanists, astronomers, and ecologists here in America. In celebration, we're dancing for everyone. They always tell us, first dance is for the whole world. Second dance is for our country. Next is for our state. Next is for the Pueblo communities. And then next is for our family. And that last dance, that's for us, yourself." So these core concepts, especially in this current era of thinking of the whole world, our interdependence, and the air we breathe doesn't know any borders, and the water that we need, it doesn't know any borders. To me, that really speaks to the elements of humanity that we're all interconnected, and to a life well lived and a balanced life. Another Thayer alum, Rose Untiso, graduate 2008. She's now supporting female and leaders in East Africa at the Energy for Growth Hub, scaling energy, energy for all. Rose served in the Department of Energy and was an innovation policy fellow for a US senator. Perhaps you might follow in her footsteps. At the University of Notre Dame, many moons ago when I was there, I was one of only 2 women graduates out of 40 aerospace engineers. What, don't I look like a rocket scientist and engineer? When I joined the MIT faculty, yep, there were 2 of us and 35 male, wonderful colleagues. Don't I look like an engineer and rocket scientist? So I did have the distinct honor to serve in the Obama administration. As the number 2, that's the deputy, I was the 3rd female, but as the first engineer. That's what I was really proud of. I was following in the footsteps of my great mentors, Professor Bob Siemens, who led the Apollo program and for whom my chair is named, and Professor Hans Mark, who led all the technical matters of the space shuttle era. Bob Siemens served as an advisor to 5 US presidents, starting with President Kennedy. That's an example of an engineer making a difference. I wanted to learn everything I could from him. And Hans Mark, when I got the job, sent me 3-page letters, old school, handwritten. The first page, all about sailing in the Chesapeake. Super personal. We'd share the joy of sailing and racing together. The second and third pages, well, they were pretty critical. All right, David, here's your leadership. Here's what you're doing right. Here's what you're doing wrong. And he would tell me his failures. Super important, because he didn't want me to, repeat those mistakes. He wanted me to thrive. At NASA, I gave an award, Lean Forward, Fail Smart. Lean forward, fail smart. We had to change the culture because people were running around with T-shirts on them that said, failure's not an option. No, wrong message. As engineers, how many of you out there, class participation, are comfortable with failure? Oh, yours, awesome. Me, not so much. I'm still working on it. That's why I teach students, okay, failure, we're engineers, right? Try again. It's the iterative design, because we know when we get it right, we're gonna nail it. One of my favorites was, lunar landing mission. So the applications I got for my failure award were fantastic. So these are some engineering lessons. Lesson 1, you all belong to the engineering profession. We need you. The world needs you. Let's provide an inspiring, welcoming environment for our moonshots, for our dreams of the future. Lesson 2, seek out incredible engineering mentors. Lesson 3, take risks. Don't be afraid to fail smartly. Lesson 4, being first, second, or third, that's not important. It's actually when we stop counting, we'll know we succeeded. We want to reach infinite diversity and infinite combinations, or IDIC, thanks to Star Trek and Gene Roddenberry. Now I'd like to share 4 additional themes or lessons, simple advices that might resonate with you, maybe spark in you. It's my teaching philosophies. Love, act, discover, and innovate, or an acronym LADY. Love isn't a word that we hear a lot in engineering, but it has to be at the heart of everything we do. One of the pledges of a professional engineer's creed is that we serve humanity. I quote, "Engineers shall place service before profit, the honor of standing of my profession before personal advantage, and the public welfare above all other considerations." Service before profit, public welfare above all other considerations. I call that love. It's the love of our profession, compassion, empathy, and love for our fellow human beings, and love for the entire planet, which I call Spaceship Earth. It's urgent that we heal Spaceship Earth. Our scientific data shows without a doubt that Earth's vital signs are speaking to us. Are we listening? Vital sign 1, temperature. Global average temperature is up 1 degree Celsius since we started keeping records in 1880. 19 of the warmest years have occurred since the year 2000. Vital sign 2, carbon dioxide. This morning I checked, and CO2 emissions were at 417 parts per million. We don't want to be above 400 parts per million. So, what can we do about it? We have the highest carbon dioxide levels in the air in the last 650,000 years. Vital sign 3, sea level rise. 99% of the world's fresh ocean is trapped in the Greenland and Antarctic ice sheets. Each year, just this year, we lost 427 billion metric tons. We've been losing that each year since 2002. Just for reference, that's the size of Texas each year. Lost. Fresh water causing our sea level rise. So, big challenges. What are we going to do about it to heal Spaceship Earth, keep our oceans, land, and air healthy? You're engineers, you're problem solvers. You have the best ideas literally on the planet to get after these. We're all astronauts. I'm here to tell you today, give you your astronaut wings, your crew. We're all in Spaceship Earth. You've been living in isolated, confined environments during this incredible pandemic. Guess what? We're all here. We're the lucky ones. We're here. We literally train astronauts in isolated, confined environments. So your dorm rooms hopefully weren't that harsh. Now we're emerging. So first, you're all astronauts. We're all crew. Let's be very active crew together. I remain very optimistic that collectively we'll listen, we'll see and understand our impact, and we'll change human behavior. We'll take the corrective action that's needed for betterment of humanity and for the Earth. For our children and grandchildren, we should all commit to leaving Earth better off than how we find it today. In the words of Bucky Fuller, we must make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without any ecological or disadvantage of anyone, end quote. Dartmouth engineers, you will turn the impossible into possibilities. Ultimately, engineering, science, exploration, and discovery are about raising humanity's potential. Investment in science, research, and technology helps us just reimagine our energy distribution systems, helps us cure disease, feed the world, and enable exploration of the oceans and planets. The science and technology research is the lifeblood of a high-tech economy and plays a critical role in our well-being. Graduates, a glimpse of your amazing dissertations. Congratulations for all the award winners. You truly inspire all of us. That's why we're faculty. That's why we're professors. Every day we get to get up and interact with all of you. You have already discovered so much. A couple of the titles for your dissertations: analysis and design of the hybrid switch capacitor converters. The energy challenge, check, you're on it. Imaging for fluorescence-guided surgery in head and neck cancer. Disease, check, you're on it. Electrical impedance monitoring for intracranial trauma. Health, check, you're bringing your best to the table. Co-treatment of cellulosic biomass. Environment, check, you're on it. So we are in very good hands. We are in very good hands with you leading the way and really using all of your engineering skills. I think one of the most important things we can do is to advance transdisciplinary education and inspire young people to confront the complex societal questions that together, through innovative revolutionary technologies and disruptive business models, and make equitable policies. Embracing the ancient wisdoms from tens of thousands of years of humans' lessons. This is how your generation, you're the Mars generation. I call you all the Mars generation because it's going to be one of you that first steps on Mars. Not me. It's you all. It's your generation. We will become interplanetary. It's not option B. Sorry, Elon. It's so that we can learn about ourselves. It's so that we can learn about ourselves and do better here for everyone. So you are our national leaders and our international leaders, and you will develop these innovations that literally get us to Mars, or Earth-based, energy and environment solutions, biomedical, medical solutions here to really lift up humanity. That is your potential, and you're already on it. So your time at Dartmouth has been indelibly impacted by tremendous global and national upheaval. From the pandemic to the isolated confinement to global wars and destruction to devastating gun violence here in the US. I commend you for all your determination and perseverance just to make it to this beautiful graduation weekend. And so I'm so honored to congratulate you. I encourage all of you to take your experiences, the insights, the compassion that you've gained, to continue your professional lives of discovery, achievement, and leadership. See and show love for those around you. Act wherever and whenever you can to help address society's inequities and the health of the planet. And of course, always reach for the stars. Ad Astra, Mars is just beyond the horizon. My wish for you is heartfelt love, that you act beyond your comfort zones, taking some of those risks that just will pay off. And that you discover your true passions and use your engineering skills in those pursuits. And that we collectively innovate a bright trajectory for future generations, 7 generations into the future. A path forward where future worlds and societies flourish because we reflected, we asked the right questions, we listened to one another as well as the planet, and we chose love, compassion, and peace over hate, violence, and war. Congratulations, Dartmouth Engineers 2022.
Thank you so much, Professor Newman. Such important words of wisdom to share with our graduates. I'm now pleased to announce the conferral of hoods on our degree candidates. Graduates, please approach the platform using the stairs to your left, my right. And once you have been hooded, please pause for a photo and exit the platform using the stairs to the left. We will not be shaking hands today, but elbow and fist bumps are welcome. Please welcome Professor Van Sitters and Professor Parker, who will be assisting with the hooding, and Senior Associate Dean Laura Ray, who will read the names of our graduates. We'll begin with candidates for the degree of Bachelor of Engineering.
For the degree of Bachelor of Engineering, Abigail Marie Brazil. Catherine Edelman. Samira Afreen. Simon Andrew Agnew. Kieran Uhern. Carolina Almonte. Omar Al-Said. Peter Benelak Ammons. Valeria Denise Andrade Solorzano. Garrett David Andreen. Ethan Finn Alwis. Unive Avendaño. Adam Bailey. Bogdan Belincevic. Maynard Bebo. Sofia Blahova. Sergio Bobadilla. Theodore Samuel Bronk. Ashley Brown. Grayson Campbell. Jason Carpio. Dylan Chan. Eric Chen. James Noah Cowie. Ian Cruz. Michael William James Cullen. Caleb Teen Dao Dang. Jackson Oliver Danis. Bridget Sharalee de la Cruz. Joshua de la Cruz. Ivana Dewich. Javier Esteban de Solis. Jack Aaron Firestone. Hannah McLean Gavin. Gustavo Gil. Adam Peter Glick. Francesco Van Guarneri. Daniel Amposana Jumpo. Clara Hahn. Isaac Hanover. Salim Hasseri. Noor Busam Osama Hayek. Shane Hewitt. Ashante Fernando Hill. Maxwell Julian Shaw Holden. Carlotta Hopkins Guerra. Nate Houston. Agon Hacha. Sharina Huang. James R. Jones III. Anush Khan. Michael Killian. Athia Nilesh Kocha. Aluafemi Toluwa Kola Jabutu. Carolina Lago Pena Maya. Kevin Daniel Larkin. Hanjun Lin. Yerkidis Maria Marmo Contreras. Benjamin J. Martin. Emily Diane Martinez. Brian Mass. Sayuri Thais Miyamoto Magnabosco. Basil Bernardino Montagnazzi. Glendora Ann Murphy. Tyler Ian Neath. Robert Barrett Noon III. Michaela Ann T.U. O'Brien. Carter Cothney Person. Daniel James Fan. Vanessa Pinney. Grace Q. Shailene Himanshu Shah. Musab Shakil. Shiny Sivakumar. Suraj Shrivats. Tyler Stern. Garth Verdaflor. Luis Daniel Verdi. Stepan Verbic. Abigail Wilson. Derek Wilson. Yutong Linda Shah. Junsing Ivy Yan. Emerald Zhu. For the degree of Master of Engineering, Holland Bloomer. Seth Winship Gilbane. Maxwell Brooks Rapier. Muri Rasanaivu. Francis Joseph Sapienza. For the degree of Master of Engineering Management, Yvonne Cornish Morales. Luke M. Amen. Adejad Sola Oriuluwu Antada. Naya Barty. Kiev Gambrill. Denise Kalish. Sneha Kumari. Alex Morgan. Giselle Christine Perkowski. Ginny Suresh. Peter Joseph Edvard Unger. For the degree of Master of Science, Sven Isaacson. Shannon Kosman. Tucker Elton Odleifson. Simon Ethan Oster. Haley Richards. For the degree of Doctor of Philosophy, Alicia Kalen Everett. Daniel Alexander. Wei Deng. Joshua Elliott. Hannah Jean Favreau. Sunchari Ghosh. Ben Goldberg. Kahari Jarrett. Michael Andrew Coco. Eldred Lee. Chen Lee. Mikhail Mara. Prescott Hampton McLaughlin. Rachel Diane Osmondson. Mabuber Rahman. Alberto Ruiz Larevu. San Shu. So Young In. Congratulations, class of 2022.
Well, congratulations, graduates. While I have everyone's attention, I want to make a quick few important announcements. At the close of the ceremony, graduates, faculty, and platform party recess immediately into the Class of 1982 Engineering Computer Science Center, the new building, for a class photo. Photos and videos from Investiture will be available on Thayer's Investiture page in the coming weeks. Family, friends, and guests, I invite you to join us at the outdoor reception outside that new Engineering Computer Science Center for beverages and refreshments while graduates take their class photo. And for students and faculty taking part in commencement tomorrow, Dartmouth undergrads earning a combined AB and BE meet at Lead Arena no later than 8:15 a.m. I'm told the doors to Lead will be locked shortly thereafter. And graduates earning the BE, MEM, MEng, MS, and PhD meet in front of Wentworth Hall at 8:30. And faculty, please meet at the front entrance to the Hopkins Center, also by 8:30 a.m. So finally, I want to close with a message for our graduates. As Provost Coates mentioned earlier, it's quite fitting to celebrate this milestone in your journey through Dartmouth, right here in the beautiful new West End. Some of you may remember the frigid day in December, about 3.5 years ago, when Dartmouth first broke ground to begin construction on the buildings surrounding us. How easy it is now to forget how our walls and floors shook, or the clanging that reverberated in our ears long after the piling had stopped. But it seems that the passage of time, plus that magnificent grand staircase in the 82 Center and the lattes and chocolate chips from Fern Cafe, have a way of helping us forget. This circle where we hold this ceremony is both literally and figuratively where engineering, computer science, energy, entrepreneurship, and the liberal arts align with your academic passions and accomplishments. This corner of campus, with our magnificent facilities with sunlit atriums and open labs and classrooms, is where students and faculty from across Dartmouth come together, learn together, discover together. This place is the embodiment of something that has always been a part of the Thayer ethos, that engineering is never a solo endeavor, that we engineers alone, no matter how skilled, our expertise alone, no matter how vast, and our perspectives alone, no matter how valid, are just not enough to tackle the world's wicked problems. Challenges so complex, contradictory, and perplexing in nature that seem impossible to solve, they require multiple perspectives. The most difficult of problems, whether it's climate change or the energy crisis, deepening economic inequality or cyber threats, terrorism, gun violence, food insecurity, global health, those problems will always require the collaborations and contributions of many. And each of you will be part of the generation that helps provide the solutions. This may feel daunting, but we have already witnessed what you are capable of. We followed your capstone projects from idea to prototype, from your research projects from limited understanding to publication. And we have watched you try and fail, then try again and again until you broke through. We watch you translate your research into something tangible and plan the process of getting much needed technologies and tools into the hands of people who need it most. In this graduating class alone, you have already made incredible headway in helping our world build smarter energy grids, found solutions to safer food production systems, invented life-saving tools for cancer detection and treatment, and developed better vaccines and therapeutics for fatal illnesses. And in the process, we have watched how you have approached problems as every Dartmouth engineer should, from a human-centered angle, by bringing together teams with diverse skills and backgrounds, by asking the hard questions, by not being afraid to fail, as Professor Newman reminded us of today, all while keeping human need and impact at the fore. And so tomorrow, after commencement, as you disperse from the green onto your individual paths, whether you enter the workforce, return to the labs, or continue on to earn a higher degree, you'll find that the world we live in is still very much polarized, divided by ideas and ideologies, unfortunately divided by race, gender, and culture, divided by boundaries that we see and boundaries that we don't see. And these boundaries will cause frustrations and create obstacles to the problem solving that lies ahead of you. And so at these critical points in your lives, I hope you will remember this exact moment and the significance of the place where you sit now, at the intersection of engineering and computer science and energy and design and business and the liberal arts, at the intersection of different perspectives and backgrounds and experiences. And I hope you will remember that inside these very buildings, in your classes, in your labs, you have worked to overcome some of these challenges and cross these boundaries. So build on that experience. Be the one who reaches across those divides. Stay open to new ideas, to new experiences and opportunities. And be resolved, because Dartmouth engineers always persevere and have never been about getting it done alone. Our world needs all of you. Congratulations.
As is tradition, I'll put all the black books, all the big folders back in the big rollie.
All right. Big rollie.
In the big rollie! Great, everybody. Thanks so much.